So we'll try to discuss few things here. So what we have, let us first see. So we have a real number system and inequalities. So n will equal to set of the rational numbers, w is set of whole numbers, z or I is set of integers, q is set of rational numbers, r is set of real numbers, set of positive real numbers is r plus, and r minus set of negative real numbers. That's fine. Rational number can be written as e by b, where e and b are integers, b is not equal to 0, and SCF of a and b is 1. That is the basic case. All recurring decimals are rational numbers. Whenever it is recurring, so it is a rational number. Those values which neither terminate nor could be expressed as a recurring are irrational numbers. There is root 2 pi minus 1 by root 3, like this. Real numbers are represented on the real number line, negative infinity, then minus pi, minus 3, like this, minus root 2, and similarly 0, 1, root 2, 2, 3, 4, 3 pi, etc. The set R represents set of continuous. The set R represents set of continuous values, not discrete values. Okay. The set R represents set of continuous values, not discrete values. Here sigma, here infinity symbol, not real number, used for extremely large value. The symbol infinity depicts that number line can be extended further. Symbol infinity, whenever you say, it is not definite. It is not a distinct, you can say. It is a continuous thing, means it can be extended further on that particular part. Okay. And the symbol infinity mean extreme right side of real number line. Minus infinity means extreme left side of real number line. Intervals as subset of, so intervals as subset, that also we know, that's why I'm not writing right now. Intervals as subset of set R. Let us define different subset of R. Let A comma B belongs to R and A is less than B. So this we can just try to understand, maybe in brief. Okay. So basically, let A comma B belongs to R and A is less than B, then open a curly bracket X, so that A is less than X and less than B. This is called as interval. Now this is interval. This is interval. This is interval. Okay, and interval name is what you can see. It is an open interval. Open interval. Okay, and plotting a real number line will be like this. So there will be line from here. Again, there will be a line from this side. Okay, but you can say simple. So here it will be, so it is not connected, I can say, right? So basically this is open interval, that's why we're writing like this is A, this is B. Okay, plotting on real number line, on real number line. This is the plot on real number line. Okay, no problem. This is the plot basically. Okay, now we have written this. Okay, and curly bracket x such that x is greater than a and less than b, so it is an open interval. Similarly, or this can be written as x belongs to a comma b, it is an open interval, or x belongs to open interval a comma b. Like this we can also write. Now let us write some other things. Let us write few other things like now x says that a x is you can say less than equal to x, is less than equal to x, and it is x is less than equal to b bracket, so it is a closed interval. This is called as a closed interval. This is called as a closed interval, and here the things will be different a bit. So we are taking a arrow here this side, and we are again taking an arrow here this way, and the middle will be obviously a straight line. So I'll just try to make a space here. So basically like this we can have, and then this will be colored. It will be a closed interval. No, that's the reason. This is a closed interval. That is why we can say that this is the value of A and B. It is a closed interval. Okay. This is a closed interval. It's very, very important thing. And this can also be written as x belongs to closed interval A comma B. So A comma B closed interval means x is equal to A also, B is equal to B also, and less than B and greater than A. Now closed open is also a case. Closed open is also a case. Let us try to understand that also. So for closed open, basically what we do, whenever we have x such that x is greater than or equal to A but less than B, this can further be written as x belongs to closed interval on A side and B is open. This is B is open. I can say that it is called as closed open interval. It's called as closed open interval, and here we can say closed open interval. So here I'll just put an arrow here this side, and again one arrow here this side will put. but there are a few other things I'll try to do in between them. So this will be closed and this will be like this. So it will be closed here. Okay. So we can write here, this is the value of A, this is the value of B. Okay. The closed open interval, or we can also write this particular part as X belongs to closed from A but open from B. Now one more way we can do for everything. So here open closed we can also write the last one. So X is such that it is less than X is greater than A but less than equal to B. Okay, or we can say X belongs to A comma B is closed here, or X belongs to A comma B. So this is open closed open close interval. This open close interval, and this will be like this. So in between them I'll just put up here few things. So this will be colored this time because this is closed B, this is A, and this is demonstration. The number B minus A is called the length of any of the interval. Okay. The number B minus A is called the length, is called the length of any of the intervals A comma B, A comma B, like this also closed interval, closed open or open closed. So clearly we can say that A comma B is a subset of A comma B which is closed, but A comma B, open interval of A comma B is a subset of closed interval of A comma B, but closed interval of A comma B is not a subset of open interval. So this is an important point to understand, right? Okay. So here also I'll just mention 1.1. So a little break for my end for this also. It will be slow, I understand, but steadiness will be there. So that's fine. It's not visible, no? Completely, there is a thing. So try to see if visibility will work out or not. I think that will work out because now visibility is there. Better than this is not possible. So it will be better if I show all of these. Okay. So that we have started discussion. Okay, then there's no